What's going on, guys? Welcome back to the channel. Hope you guys enjoyed the last video that I put up. Now we're going to switch it up. This one's not going to be part of the Naruto and networking series. This one's going to be more personal to me. So let's just do a quick recap. Part of the reason I'm putting up these videos is because of the mass migration, it seems, for people to leave whatever other industry or line of work that they were doing to come into the tech world or the IT world, right? Again, this is a universe in itself. Honestly, world is the wrong word. It is a universe in itself. So many different specializations, whatever industries you want to go into with a particular job title, things like that. It can be a lot. My first IT job was very interesting because it was a part of IT that even I had never heard of. Keep in mind, my mom has worked in IT basically her entire career, or tech her whole career, while she was in the Navy, and continues to work in cybersecurity now that she's out. I've always kind of heard some stuff here and there about IT and the different sides of it, just not a whole lot. But my first IT job was very interesting because even my mom had never heard of it, which is called e-discovery or electronic discovery. This is a tech role or a specialization that deals with legal data, right? So this was a job or specialization that focused on legal data. Hence the word electronic discovery, primarily the discovery part, which is a legal term. Basically allows you to find information or data whenever someone's getting sued, aka a litigation kicks off, and you're able to request any data information from either the plaintiff or defendant, depending on what side you're on. You're able to request any information that is relevant to that case and put it into a centralized database that analysts on both sides can use to give that information to the lawyers when they have deadlines and need to show up to court for cases and things like that. That's pretty much what e-discovery centers around. So e-discovery, it was interesting. From my understanding, it's considered an other side of a coin or something that goes hand in hand with cybersecurity, but they're not necessarily the same thing. I've also done some research and have seen articles that have essentially said that e-discovery falls under the cybersecurity umbrella. It's very weird. There's no straight answer for it. But I will tell you this, getting that job, or rather functioning in that job, was fairly difficult to me because one, my education was not based in technical IT stuff. Both of my degrees are basically business based. It's just that my second one is more geared towards the business side of IT. And my personal experience of being technical, not really there. I've never worked in anything like networking related, hands-on with hardware, servers, and things like that. That just wasn't my experience. So for this role, it was entry level and they were willing to teach you. They definitely were. But it was so much technical stuff that I just was not able to learn quick enough while I was there. So I want to go over things that I wish I knew before I had landed that job, that if I was to get that job now, I am extremely sure I would be able to do the job without too much of a problem, aside from maybe a few extra details. Part one. This one revolves around pretty much the cornerstone of the entire job, at least for the discovery job that I had, which basically data loads. One of the main things, if not pretty much the main thing that our job revolved around, was data loads. Like I described earlier, the whole thing with e-discovery is getting data or information whenever someone's getting sued and the litigation process kicks off. You hand it to the tech company who that takes that information and uploads it into a legal document or legal data website or web application. And that allows analysts on both sides to be able to look at this data, mainly the lawyers, and then from there they can come up with their case and win in court. That's the general idea. The thing with the data was you had to do many types of different data loads. We were able to do internal data loads, which was pretty straightforward. If you're familiar with the concept of data mapping, which is something we'll probably hold off on deep diving into until later if necessary. But if you ever done anything with data loads, you're familiar with mapping the data. Basically, if you know Excel, think of columns, like column names, and you're using Excel. Imagine that you have one file, one Excel file with a bunch of different column names, and you have another Excel file, and it has column names too, but it's different than names in the first one. That's pretty much the type of thing I had to deal with, except with internal data loads, our internal processing team would process the data so that those column names matched. That way we knew what information had to be loaded into what column into the centralized website, into the website that the analyst will be able to use so that the lawyers and other people would be able to access this information whenever they needed to get ready to go for a court date, right? So internal data loads were a little bit easier. Here's where things were a little weird. Third-party data loads. This is something that threw me off a lot. And even when I thought I finally understood it, I still just kept making mistakes over and over again. So third-party data loads were when data would come directly from the external company, like one of the companies that's part of the litigation, whatever side they're on, but it wasn't processed by our internal team. So what happens is we're getting all this data from a third party, an external company, and the data, at least by column name, doesn't match what we have in our system. So at that point, we need to dig a little deeper. We need to take a look at what type of information is actually under these column names or fields. In tech, people will call the columns fields. We'll probably touch on more on that later too. But the field names don't match, because that's like saying, for example, if I call, basically it's like soda pop, honestly. It's like, depending on what section of the country you're from, and my family's from the Midwest. Both of my parents, most of my family from the Midwest. So it really grinds their gears when people, I think for them, they're from Cleveland, Ohio. So I think for them, it's pop. And whenever they hear someone say soda, it just rubs them the wrong way. Me, I'm from California. I honestly don't know if it was ever a big thing for us, but it's kind of like that. You're referring to the same thing, but when you're going by the name of it, you don't know. It doesn't match. So you, depending on like how clueless you are, you're going to have to do a little bit extra research there. It's kind of like that. If you have one column that says soda and you have another one that says pop, you may not inherently know what someone's talking about. So you need to look at the actual things under that column to say, oh, okay, these are the same things, the same like values, brand names of the soda pop companies and things like that. Like these are the same things, but the category name is different. So you have to do a little extra research there. There are some other things too, which brings me somewhat to the second point under this, metadata. So for those who don't know, this might sound weird. Metadata is data about data. Quick example. We're so social media driven. This is the social media information age, everything like that. You know what I mean? The thing with pictures, videos, reels, all that stuff, videos you record on your phone, it has data about, for example, where did you take that picture or record that video? What time of day? The coordinates, which again is like your location, country, state, city, stuff like that. That is metadata. When you have pictures, photos, and things like that, the metadata gives you more specific information, mainly pertaining to the creation of that file, right? So sometimes the metadata, we would have to clean it up a little bit. That one was data loads and mix matching of the different column names and understanding why, one column name would be different to another one, but why they would contain the same information. That was weird. But now with my current job, and now that I've spent enough time away from it, the concept sits pretty well. That, and I've come to understand relational databases pretty well, which brings me to part two, relational databases. Now, relational databases, I pretty much already covered this one with the soda pop example. The thing with relational databases, again, is that one database may not be the same. If anything, two databases, it's very unlikely that two databases will ever look exactly the same. It's very unlikely. But before I get too deep into this, I want to clarify what a relational database looks like. You're familiar with the term, but I want to make sure you know what this looks like. Now, this is going to rub some people the wrong way, but if you want to get a good idea of what a relational database looks like, at least in theory, if you've used Microsoft Excel, you pretty much already know what it looks like. Here's the whole thing. The data is relational because you have rows and columns, or fields. Like I said earlier, we tend to call these fields, but rows, columns. It's like multiplication tables. You're trying to go over the multiplication, the different multiples for the number 4, right? So you have 4 here, and then you're saying, so if you're multiplying 4 times 1, you need to find 1 over here, find where it matches, there's your answer. You're multiplying by 2, find 2, you have 4, find where it matches or where they intersect, and that's your answer. Relational databases work basically in that same way. When you have a column and you have, let's say, a person's name. If you're trying to find the salary that Jon Stewart makes, and you find where those two spots intersect, you'll find his salary. That's what makes it relational. The two key data points, the row and the column, they lead you to a specific answer and they relate to one another. It's very organized that way. Versus non-relational databases, they don't do that. It's more like a list. It depends on the database, but they tend to be more like consistent, like shopping list type databases. So there is no, here, meet here, there's your answer. Non-relational databases don't do that. With relational databases, one thing that I wish I understood, again, was the whole name difference thing. When you have data coming from one database and you're trying to load it into another one, again, chances are they're not going to look the same. So you're going to have to do extra deep diving and research to be like, okay, do we have a column or a field that matches the information that's being given to us, but it's under a different name? If we don't, then we're going to have to create a new field or column in the system. That way we can upload this data where it belongs so that it's not missing. When information is missing, that can cause problems, especially because, again, e-discovery deals with legal data. It deals with lawyers and things. You do not want to mess their stuff up, right? Especially when it comes to their deadlines and things. So we need to be very on top of that. But that was something I didn't understand at the time. So that was another thing that I wish I had already known prior to me, doing that, getting that job and having to take on that type of job and learning this information relatively quickly. Another thing about relational databases, and I made an extremely big mistake with this. Please don't make this mistake. I'm sure most people don't, but you never know. Please don't make this mistake. So another thing with databases, for those who don't know, the whole point of a database is to store data, but that data is also being actively used, right? The database, it stores data that people use pretty much on a regular everyday basis, but it also allows security features like, are you allowed to access this type of information? And also make sure that the information is accurate and a bunch of different things. Something called integrity, which is part of the CIA triad. We will definitely touch on that later, but we won't deep dive too much into that. But that's the basic concept of databases. It contains a whole bunch of data that is actively being used. If you're not actively using that data, chances are you need to put it into an archive. Now, here's the thing. Databases need to be backed up because when you have, let's say, like a mobile app or a website or a web application, you don't want it to be relying just on one database, because if that one database goes down for whatever reason, a lot of things can start going downhill. For example, one of the benefits of a database is that it saves your user data so that your experience with the website or web application that you're using is unique to you. For example, Amazon. Everyone knows about Amazon. I'm sure everyone uses Amazon profusely these days. You can't not know Amazon at this point. But everyone's Amazon doesn't look the same. Everyone's Amazon account most likely does not look the same. That's the result of a database on the back end that we don't see. Because, for example, you have orders that you've placed. You can go to the orders tab in the website and see the list of orders that you've made. In Amazon, for Amazon, their database is what's holding all of that information, say on this day, this time, with this pricing and stuff like that. You made this purchase and this is the order number for it and things like that. That is something that's good for a database. When you don't have a database, you're not going to be able to see that your order history, and it's not going to be able to use that information to customize the website for stuff that is more unique to you. So what was the big mistake that I made with the database, when I was working in e-discovery? So with databases, you have to back them up. It's just like everything else. You want to back it up so that, for a couple different things. One, certain pieces of data are easier to find. That's where indexing comes in, but we're not going to touch on that yet. But the main reason being, it makes sure that the data is still there. It doesn't just disappear. Because if you load data into a website or into, just some place where the data is going to be used, but you don't back it up into the database, there's a decent chance that the data is going to be lost. That's why you need to back it up. The thing is, there are multiple types of backups. You have incremental, differential, and full backups. The thing is, you never, ever, 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 you never want to do a full backup in the middle of the day, when the mass majority of people are using data that is being pulled from that database. The whole point of a full backup is to wipe the backend database clean and to build it back from scratch. The thing is, if you have tens of thousands of people that are using data that is stored in that database and you kick off a full backup, you just delayed a lot of people's work and made their day probably much worse and a lot harder and stressed a lot of people out. And the thing about databases these days, databases are full of a lot, and I mean a lot of information. It's not like okay, it's just gonna wipe it clean and builds it back up in 5 minutes. No, like this can take hours, like maybe half of the day. Half of the day might be spent just to getting this thing back up and running. And until then, you're pretty much stuck. No one can do their job. No one can do anything at all. And unfortunately, I made that mistake. So yeah, that was pretty bad. So you want to make sure if you're dealing with a job where you interact with databases directly, or at least perform database backups to some degree, make sure you don't ever do a full backup, ever. Like the only time that should happen is like overnight when there aren't really many people, if any at all, using that database. Then you can do it because nobody's job is going to be messed up. Now, before I move on, how did I end up making this mistake? Basically, I tried to do the proper backup, which was an incremental backup after I performed the data load. But when I tried to do the backup, it didn't work. It just stopped. Like I waited a few minutes and was like, the backup's not starting. Why? Now, it wasn't until after the fact when I learned, my manager at the time told me that chances are my request to back up the database was in a queue. I just couldn't see it. There was no message. I couldn't see it. I couldn't interact with the actual backend database itself. So I just pressed the backup button and it grays out and it just stops. And I'm just like, what's going on? Why isn't this working? So to try to do my job right, that's when I kicked off the full backup. And that's when everything went downhill. And I found out that I shouldn't have done that. And if I had just waited maybe a few more minutes or just however long, my backup eventually would have kicked in. It's just that so many people were most likely submitting database backup requests so much at the same time that it caused my request to just not happen right away, which had never happened up until that point. So I didn't know any better, but now I know. But all right, guys, I think I rambled on enough. I actually enjoyed recording this video a lot more than I thought I would. Just looking back on that first tech job, the mistakes I made, what I learned from it, the fact that I have internalized that information, that experience now, and I know what not to do when dealing with certain things. So hopefully this video was as helpful to you as it was for me. But yeah, if you guys got any feedback for me, go ahead and drop that down in the comments for me. I'll see you in the next video. Peace.